Hey there everyone, welcome back to another video. Today we are back continuing the series 06CHEM20. This is episode I think 5 or so and chapter 4. Chapter 4 is basically electrolysis or electrochemistry, which is electricity and chemistry. The first part is electrolysis. So let's begin. Now, define electrolysis as the decomposition of an ionic compound, blah blah blah. So basically, when you're defining electrolysis, right, there are some few key terms that you need to include, which is electrolysis is the breakdown. Instead of decomposition, I prefer to write breakdown. Or let me just write that down here. Okay, so electrolysis is the breakdown of an ionic compound through the passage of an electric current when molten or in the aqueous solution. That's an easy way to write it instead of the way it's given here. You'll still get the same mark. Identify in simple electrolytic cells the anode as the positive electrode, the cathode as the negative electrode, the electrolyte as the molten or aqueous substance that undergoes electrolysis. So basically, if you watch the first episode of this series, you'll notice that we said anion are negatively charged ions or negative ions, and cations are positive ions. Now basically, when you look at cathode and anode, okay, these electrodes are just the opposite of them. If anion is negative, then anode is positive. If cathode is positive, then see, it's kind of a bit confusing, but you'll get it. Okay, if cation is positive, that means cathode is the opposite, which is negative, and electrolytes is the molten or aqueous substance which undergoes electrolysis. So you can show it like this. Okay, you have your beaker like this, and you have your electrode over here, and you have another electrode over here, and they're connected together using a cell. Now the bigger side shows positive and the smaller side shows negative. That means that if it's positive, this is my anode, this is my cathode. Okay, then my electrolytes will be something like this. Okay, now electrolytes can either be molten or aqueous, but it cannot be solid. Like this electrolyte cannot be in the solid form. Okay, because you'll have the ions won't be able to flow, they'll just be there stuck in one place, right? Then okay, let's go down here. Identify the products observed at the electrodes and describe the observation made during the electrolysis of molten lead 2 bromide, blah blah blah. Okay, so now when you have molten lead 2 bromide, right, so which is basically PbBr2, if I'm correct, the observation that will be is that because bromine is negative, right, it's an anion, so it will move towards the anode. Remember this, anion moves towards the anode and the cation moves towards the cathode. So at the anode, you'll see a red-brown gas with a pungent smell, and at the cathode, you'll see a lead 2 solid or crystals form. Then when you go to concentrated aqueous sodium chloride, which is basically NaCl. Now whenever they say aqueous, right, you'll have your Na plus Cl minus, and you'll have H plus and OH minus. Now over here, when you're selecting from this plus and this plus, the least reactive metal will go to the cathode, which is H. You need to know the reactivity series, which is please stop calling me zebra, instead learn how copper saves gold. If you don't know this one, you can check out my YouTube shorts, it's in one of them. So if I see where sodium is over here, hydrogen is over here. Since hydrogen is less reactive than sodium, this is what will go to the cathode. Now remember, whenever they say concentrated, right, that means that always the one over here will go, the OH will never go. And whenever they say dilute, we don't care about what is here, it's always the OH that will go. So just remember these two tricks in order to remember. Yes. So when you have concentrated aqueous sodium chloride, what's going to happen is that at the cathode, hydrogen gas will form where you'll see effervescence or bubbles. And since chlorine ion is going to the anode, you'll see a green-yellow gas with a choking smell. When we come to dilute sulfuric acid, we have H plus, SO4 minus, and you have H plus, OH minus. Now because it's H plus, any of the H plus can go, and because it's dilute again, you'll see that it's the OH that goes, right? So observations, because of the H plus at the cathode, you'll see effervescence or bubbling, and over at the anode, you'll also see effervescence or bubbling because oxygen gas is produced, which is colorless. Then it says use inert electrodes made of platinum or carbon or graphite. Why? Because because they are good conductors of electricities and they are inert. Inert means that they do not take part in the reaction. Okay, they do not take part in the reaction, they just conduct the electricity and do the work. State that metals or hydrogen are formed at the cathode. So only metals or hydrogen can be formed at the cathode, whereas non-metals are formed at the anode. Predict the identity of the products at each electrode for the electrolysis of a binary compound in the molten state. We basically did that over here. State that metal objects are electroplated. Okay, very important. We need to talk about electroplating. Okay, so electroplating, why do we'll come over here for electroplating somewhere. Think somewhere. Okay, never mind. So describe how metals are electroplated. Great. So basically, why do you electroplate is a question that they usually ask, or why are metal objects electroplated? Remember that it's metal objects that are being electroplated to improve their appearance first of all, and to make them resistant to corrosion. Now when you move ahead in the chapter, you'll notice we are going to be talking about corrosion and rusting, where you will then remember that this is why we electroplate a metal. Describe how metals are electroplated. So basically this is how it works. So you have an anode and you have your cathode. One of the object is going to be the this thing is going to be the one that you want to electroplate. Suppose I want to electroplate a metal. So at my cathode I'll have my metal that I want to electroplate, and I'll have my anode over here. Now note that the electrolyte will be an anode salt. Okay, that means that if my anode over here is, let's say I want to coat it with copper, then my electrolyte over here will be copper 2 nitrate. Okay, that means this is my anode salt, right? So basically what will happen is that the copper ions from the electrolyte will go over here, they'll displace on this and increase the mass and electroplates on it, whereas in order to maintain the concentration of the copper ions in the electrolyte, this electrode will lose copper ions into the electrolyte and the mass of it will decrease, so it will look something like this. Just a second. This is how it will look, and this will be covered with the copper ions. Okay, so the rate at which copper ions enter the electrolyte is the same rate at which copper ions leave the electrolyte to be decomposed over here, right? That's how electroplating works. Then we come back here. Describe the transfer of charge during electrolysis to include, let me just clean this real quick. Okay, the movement of electrons in the external circuit. In the external circuit, electrons move from the anode to the cathode, and the loss or gain of electrons at the electrode. So basically you can remember this using oil rig, which is oxidation is loss and reduction is gain. So it's oxidation is loss of electrons and reduction is gain of electrons. So at the anode is where oxidation occurs, so electrons are lost at the anode, and cathode is where reduction occurs, so at the cathode electrons are gained. So ions move in the electrolyte. So so basically what I said over here, where's that? Yes, anions move to anode and cations move to cathode. This is what they are saying over here. Then identify the products formed at the electrode and describe the observations. So we just did that. Oh wait, they say electrode of aqueous. Okay, aqueous copper 2 sulfate using inert carbon or graphite electrodes, and when using copper electrodes. So these are two experiments that you need to know, using aqueous copper 2 sulfate when you have carbon or graphite electrodes and when you have copper electrodes. Okay, so basically when you have graphite, right, the solution turns lighter blue, that which is an observation, and a reddish layer forms on the copper. When you have a copper the cathode becomes thicker because more of the copper ions stick to it, and the anion dissolves into the electrolyte. Now I didn't really explain this because I feel like I can explain it better in a video. I have to finish this chapter real quick, that's why I'll finish it fast and then come and teach it again in a different video. Predict the identities of the product at each of the electrode for the electrolysis of a halide compound or in a dilute or concentrated solution. Basically just know your basics so that you can follow what I've taught here. Construct ionic half. So yes, so what I need to do is this part and this part in another video for sure, so we'll come back to them because they're a bit broader to this thing, but let me just give you a gist of it. Since at the anode we have oxidation is oil which is lost. So if I have x squared over here minus 2e minus giving me x, I don't know how, unless I get an example, but something like xe minus or 2xe minus. So this is an example of oxidation, ionic half oxidation at the anode, and since reduction happens at the cathode, which is gain of electrons, I can have something like 2ex plus 2e minus giving me x squared. So yeah, this is what ionic equations are basically like. I'll go into details with examples in a different video, don't worry about them. Now state that a hydrogen fuel cell uses hydrogen and oxygen to produce electricity with water as the only chemical product. Now advantages of this is that it's renewable, it has no pollution, it has more energy, and disadvantages is that it's expensive. There are not many hydrogen fuel stations around the world just now. Affected by low temperature, it's expensive as I said, and hydrogen is difficult to store. Now so basically it's hydrogen plus oxygen, and they said water is your final and the only chemical product. So this is how you write it, and the overall equation could be written as O squared plus 2H2 giving us 2H2O. So the ionic equations of this will also be covered in the ionic equation video. So make sure you like, share and subscribe so that you know when I post the video. And I think that's all for this chapter. I'll see you in the next video. Till then, tada, bye bye.